So please respond. I mean, a few handful of formulae and results, which will help us in arriving at the real answer. Orbital angular momentum, 3 of orbital, xh upon 2 pi. Now, guess you know this. You know it's root over of L into L plus 1, h upon 2 pi. In terms of the orbital angular momentum, L is the number of the subcell. And naturally, for S, L being equal to 0, this is going to be 0. Yes or no? बच्चे लोग हाँ ना बोलो.
हाँ सर.
हाँ सर.
For any s orbital or an orbital in S subcell, orbital angular momentum will be 0 because root over of L plus 1 h upon 2 pi is the standard formula. We'll want to move on. Question 2. The number of atomic orbitals from this following having 5 radial nodes. Now, guess you all know number of radial nodes. Please take it down. As a formula equal to n minus L minus 1. And when the time is right, I'm going to explain this, but so many times the results would help. Number of angular nodes is equal to L. So the total number of nodes would be n minus L minus 1 plus N, which will be equal to n minus 1 only. So these are few formulas I want you to take note of. बच्चे लोग हाँ ना बोलो. What is the common answer? 3. Is 3 the common answer? 7p, 6s, and 8d. 7p, 6s, and 8d will have 5 radial nodes. Naturally, for 7p, we'll want to apply n minus L minus 1 as 7 minus 1 minus 1. For 6s, we'll want to apply it like 6 minus 0 minus 1. And 8d, we'll want to apply it like 8 minus S0, P1, D2. I think I'm being understood. 7p, 6s, 8d, and we'll want to move on. The next question is the following. Arrange the following orbitals in decreasing order of energy. Please go ahead. Tell me.
B. Bombay.
Sir, B Bombay.
B Bombay is the right answer. B Bombay is the right answer. B Bombay. D more than B more than C more than A. I think this is as simple as it looks. Naturally, the orbitals will be following the n plus L rule. Now, this is n plus L is equal to 3. This is n plus L is equal to 4. This is n plus L is equal to 5. This is n plus L is equal to 4. And every time you have equal n plus L value, the one which has smaller n value is going to have lesser energy. So naturally, 3 more than 4. So it's going to be A, and C and B with a common value 4. C will be lesser than B, and then D with the maximum value of n plus L will have the maximum energy. This is 5, I reckon. We'll want to move on to the next question. I hope I'm being understood. Maximum number of electrons that can be accommodated in cell with n is equal to 4. I'm sorry, this question is not, completely correct in the sense, you'll want to write here n is equal to 4. This was there in the problem sheet, I reckon. This is actually equal to n is equal to 4. This is the correct question. N is equal to 4 will mean the maximum number of electrons that can be accommodated in this cell or orbit with n is equal to 4, the 4 both orbit. बच्चे लोग हाँ बोलो. And what's the common answer? Please go ahead, tell me.
32.
Sir, option B.
32.
Option B.
Something which we all know, 4n square is such a known result. And 4 into 4 square would certainly give me 2n square, I'm sorry. Let me tell you.
सर 2n स्क्वायर होगा ना?
हाँ, मैं भी tell you. I'm really sorry about this. Number of orbitals होता है n square, number of orbitals होता है n square, and number of electrons is 2n square. So 2n square and 2 into 4 ka square. I guess you're all understanding me. 4 is the number of the orbit or cell. We want to move on. Next. Number of orbitals which have electron density along the axis. Number of orbitals which have electron density along the axis. I hope it's pretty readable. If some part of the question is not readable, I just want to shift the camera a bit. Is it readable now?
Yes.
Yes.
Now, naturally, along the axis, what's the common answer? Quickly tell me.
5.
5, sir.
5.
Along the x-axis, along the y-axis, along the z-axis, x, y, y, z is between the axis, x, z is again between the axis, this is along z-axis, and this is along x and y-axis. 5 is the right answer, I believe, along x-axis, y-axis, z-axis, along z-axis, and along x and y-axis. Moving on. I mean, ये मेरे को लगता है समझ में आता है x, y, y, z, z, x का स्टोरी क्या है कि अगर मान लो ये x-axis और ये y-axis है तो x, y, you know, is going to be between x and y-axis. ये y, z का स्टोरी होगा, ये x, z का स्टोरी होगा. So ये between the axis, they are non-axial orbitals and they are along the axis. Moving on. Quantum numbers for 4 electrons, the correct order of increasing energy is. You know, you see it very regularly, very common. It's about getting it right every time. I think I'm being understood. What's the common answer?
B Bombay.
B.
B
यहाँ पर
Bombay.
n plus L 6 आ रहा है, यहाँ पर n plus L 5 आ रहा है, यहाँ पर n plus L 5 आ रहा है, यहाँ पर n plus L 4 आ रहा है. Naturally, D will be the smallest, C would be the maximum, and between A and B, the one having smaller value of N will be, you know, lower in energy. So this I reckon is the right answer. C more than B more than A more than D. Certainly B is the right answer. We'll want to move on. Yes, please. Again, a very similar question.
A. Option A.
Option
I'll obviously go with the common response, which is A. And by now, you know, it's very cliche. N plus L 5, 4, 3, and 4. A would be minimum, B would be maximum. Between B and C, I'll expect C to be smaller with a smaller N value. Moving on. C. Yes, please.
C.
C.
Naturally, C is not allowed because for n is equal to 3, the possible values of L is 0, 1, and 2 only. You know, this is L certainly. You know, you figure it out. It's going to be L only. The values of L possible are 0, 1, and 2 only. L का maximum value n minus 1 हो सकता है, 0 to n minus 1. So for L, n is equal to 3, L3 is not possible. You have a doubt somewhere? You'll want to stop me. We move to question 9. Nine is a repetition. 9 गड़बड़ हो गया. There was a question in between, you know, I'm writing it down. Number of radial nodes and total number of nodes in a 4p orbital. ये ना थोड़ा सा ओटीटी तो गड़बड़ कर दिया है. यहाँ पर एक क्वेश्चन था number of radial nodes. If you refer to the problem sheet that I have given you, number of radial nodes and total nodes for a 4p orbital. Now, which is the right answer? If we go with the options,
2 and 3,
radial
option
nose,
A.
2 and 3, 2 and 3. Option A, 2 and 3 is right. So, there seems to be some clerical error. 2 and 3 naturally because radial nose, is n minus L minus 1. So, for 4p, it's going to be 4 minus 1 minus 1, which is 2. Total number of nodes naturally is n minus 1, which is 4 minus 1. Anyway, go ahead, question 10.
Option D.
Option
Option D, A, B, and C.
So you find A, B, and C correct. You find A, B, and C correct. The electronic configuration of chromium is the D5S1. Half filled is certainly right. The magnetic quantum number may have a negative value. Naturally, it's minus L to plus L. In the ground state of an atom, the orbitals are filled in order of decreasing energy. That's also perfectly all right. The total number of nodes is given by n minus 1. N minus 2 is the wrong value, so this is wrong. A, B, and C looks right. And A, B, and C right would be option D is correct. So, I'm just going to move to the options. I think you're happy with this, and we'll want to move on. Yes, please. They want the statements which are correct. Tell me which statements are correct.
A, C, and D.
sir, option
I can see somebody telling me, I can hear somebody telling me A, C, and D. A is certainly right. This comes from the Bohr's postulates. As with the quantum number, L can have a value from 0 to n minus 1, so this is incorrect. Magnetic orbital number for a particular L has 2 L plus 1 values is correct because it starts from minus L to plus L. Plus half minus half are two possible orientations of electronic spin. That's also looks good. For L is equal to 5, there will be a total of n square that is equal to 25 orbitals. So A, C, and D look right, which I reckon is option C, Calcutta. Are you all there with me? We want to move on. Question 12. Question 12. 2. Yes, please.
2.
Sir, 2.
2.
The number of correct sets of quantum numbers is 2, and which 2? B and C.
A and C.
D and C.
I can relate to the voice of Abhishek Banerjee. Is Abhishek there in the class?
Yes, sir.
Speak to me once tomorrow. एक बार मेरे को कल दिन में phone करो, हाँ? I want to speak to you tomorrow. Question 30. Naturally, this is not possible because 2 का ये 2 नहीं हो सकता, 3 का ये 3 नहीं हो सकता. Every time you have a question of this kind, it's a free scoring opportunity. 30.
Sir, option A.
A, 1 and
Sir, A, Agra.
1 and 2. By this time you are very through with this. 4 minus 2 minus 1 is n minus L minus 1, which is equal to 1. An angular node is equal to the L value, which is 2 here. Question 14.
B and C.
Yes, please.
Option D.
I can hear somebody saying D Bombay.
Sir,
Obviously, degenerate means having
same n plus L value.
Same or equal energy. Degenerate means having equal energy, which will mean having same n plus L value, yes or no? And same n plus L value is for option B, 3 plus 2, 5, 3 plus 2, 5, and they are certainly going to be a set of degenerate orbitals. Different magnetic number is about two different orbitals in the same subcell. Anything which you want me to repeat? Otherwise, we'll want to move to question 50. Valence magnetic quantum number of the outermost electron of zinc plus iron is? Yes, please.
Sir, 0.
0.
Sir,
Zero.
0.
Zinc is 3d10, 4s2. So naturally, zinc plus would have a 4s1, and 4s1 being the outermost electron will have a magnetic quantum number 0. S के लिए magnetic quantum number is 0. Azimuthal quantum number for gallium. Yes, please. Who tell me for gallium?
0.
0.
0.
What's the electronic configuration of gallium, by the way?
3d10, 4s2, 4p1.
3d10, 4s2.
4s2, 4p1.
Naturally, gallium follows zinc. So if it is gallium plus, it's still again the 4s electron for which the azimuthal quantum number L ka value is 0 for S subcell. Please stop me if there is a doubt at any point of time. Gallium, germanium, arsenic, selenium, bromine, krypton is what follows zinc. This is 31, I reckon. 17.
Sir, option C.
Option C.
Option C sounds good. No angular nodes and two radial nodes, because angular node knows value of L, which is 0 for S orbital, and two radial nodes would mean you'll want n minus L minus 1 to be equal to 2. So you know 3s fills the bill, it fits the bill, because 3 minus 0 minus 1 is certainly equal to 2, and we'll want to move on. $18.
Sir, 0.
Naturally, the answer here would be 0, because if a certain orbital has ml is equal to -3, naturally this will lead me to conclude that the value of L is equal to 3. Only for L is equal to 3, you can have ml is equal to -3. Also understand, 4 के लिए L का value 3 से ज़्यादा नहीं हो सकता. So you know, 4 minus 3 minus 1 is how I want to write for n minus L minus 1, which is the number of radial node. And the number of radial node here, you know, would be 0. I think I'm being understood. ml minus 3 would mean it's certainly 4f. This is certainly 4f. But L is equal to 4 and L is equal to 3. Yes, please, this is a nice problem. 19 is a good problem.
Sir, 3.
3.
It's a good problem. I am happy, you know, few of you are coming up with the right answer, 3. Please tell me what are the 3 values possible? Come on, I'm eventually going to give you the answer only. Yes, please, what are the 3 values for which magnetic quantum number plus C is possible?
Sir, 5D, 5F, 5G.
Give me H के समय. N is equal to 5 के लिए L का value possible are 0, 1, 2, 3, 4. I'm really sorry for this. No, this is ये सबको समझ में आ रहा है बच्चे लोग? ये सबको समझ में आ रहा है? आई होप आई एम बीइंग अंडरस्टूड. यू नो, ml का वैल्यू +2 तभी पॉसिबल है when the value of L is more than or equal to 2. So for these three only, 5D, 5N, and 5G will have orbitals with a value of magnetic quantum number +2. Please respond with a yes or no.
Yes, sir.
The possible value of ML, which is the magnetic quantum number, is from -L to +L. So +2 is possible only if the value of L is equal to or more than 2. In the sense, for 5s, you'll have 7 orbitals, which will be from -3 to +3. So यहाँ पर एक value +2 का होगा. यहाँ पर you'll have values possible from -4 to +4. तो यहाँ पर भी 2 होगा. और यहाँ पर naturally -2 to +2. यहाँ पर एक +2 possible है, यहाँ पर एक +2 possible है, यहाँ पर एक +2 possible है. So the answer is 3. Moving on, question 20.
Option C.
Yes, please.
C.
C, 5D.
5D seems to be the right answer because again for 5D, radial node would be 5 minus 2 minus 1, which is 2, and angular node, the value of L is equal to 2. So for 5D, radial node, angular node, both will be 2 in number. Please stop me if there is a doubt. Else we'll want to move on.
Sir, option A.
A.
Option A.
ये सारा राइट होना चाहिए, मतलब ये ना पता नहीं आज. Give me a minute. 21. A is right. Yes, certainly A is right. 6s, 4f, 5d, 6p. ये तुम्हें पूरा बता देना था, तुम लोग को पूरा याद रखना चाहिए. 6s, 4f, 5d, 6p. तो obvious 22. ये ना, ये क्वेश्चन है जो कि ग्रुप में भी सब लोग पूछ रहा था. ये हाइपोथेटिकल क्वेश्चन भी है, ये हाइपोथेटिकल सॉल्यूशन भी है. इट्स अ रियली मेजर प्रॉब्लम. इसका एनटीए का आंसर कुछ और है. मैं बताता हूँ. मेरे को लगता है ना कि अगर n का वैल्यू के बराबर, अगर l का वैल्यू n+1 तक जाता है तो क्या होगा? n का 1 होने का मतलब होगा l का वैल्यू वुड बी लाइक 0, 1, 2. n2 would be like L is equal to 0, 1, 2. So naturally इसके ऊपर जाने का जरूरत नहीं है. Which means पहला सेल में 1s होगा और 1p होगा और 1d होगा और फिर 2s होगा और 2p होगा और 2d होगा और 2s होगा. It's a major problem. If I go by n plus L value, if I go plus n by n plus L value, if I go by n plus L value, by n plus L value, the filling of subcells will be like 1s, then 1p, then 1d के पहले 2s आ जाएगा. इतना तक में कहानी खत्म है. 9 is the first alkali metal. 9 is the first alkali metal. So 9 would be like 1s2, 1p6, 2s1. Honestly, I don't see an objection to this. 13 is the half-filled valence cell. 1s2, 1p6, 2s2, and 1d3. I find this absolutely impossible. NT इसको पता नहीं राइट आंसर कैसे बताया था. 8 के लिए 1s2, 1p6, जहां पर पूरा p भर गया है, ये भी मेरे को ठीक लग रहा है. 6 has a 2p valence of cell is again not possible. A और C में एक राइट आंसर होना चाहिए. अब कहीं कहीं पे इसका आंसर A राइट दिया है, कहीं कहीं पे इसका आंसर C राइट दिया है. But as I told you, it's a major problem. It's like a mistake they should not have done. They got confused, in trying to give you a dubious problem. So you'll want to just, skip this one for the time being. Had I been in your place, I would have gone for either A or C as the right answer. I hope, they awarded 3 marks for this question in the real exam. Moving on, 23. Yes, please, 23.
Option B.
Option B, 2.
Option B, 2.
Yes, please. Number of subsets with n is equal to 4 and m is equal to -2. Yes, please. I want to hear some more of you. What are the possible subsets? Please name the subsets.
4D, 4F.
4D, 4F. Certainly. 4S, 4P, 4D, 4F. And in 4D, it will be -2 to +2. And in 4F, you will have -3 to +3. So, one here. And, in -3 to +3, you'll have another one here. The 4D, 4F will be the subsets with at least one orbital with a quantum number -2. B Bombay looks good. 24.
B Bombay.
Option B, Bombay, 25.
B Bombay,
25
absolutely all right. N
Bombay.
is equal to 5, n square, 25 is the number of orbitals. And in 25 orbitals, we'll have one clockwise, one anti-clockwise. I would have told you, arrowhead up or below neither means clockwise nor anti-clockwise nor plus half nor minus half. But because plus half and minus half are two quantum mechanical analog, I'll believe that for plus half or for minus half, they're going to be 25 orbitals में 50 electrons है, 50 electrons में half of them will be plus half of them will be minus half. I guess I'm being understood. 25 is indeed the right answer. Question 25. I did tell you the path. It's again a very particular type of question where the energy will be minimum. The energy will be minimum if the nuclei is the most powerful. So the energy is lowest in case of the one where the value of Z is maximum. So potassium is the one with maximum atomic number here, and that's the right way of approaching this question. Please take a note of it. Isoelectronic set of sciences. Yes, please.
A.
Yes, please. Naturally,
Option A.
N3 minus O2 minus S minus Na plus is like 7 plus 3, 8 plus 2, 9 plus 1, and this is 11 minus 1. They're all going to be having 10 number of electrons. The size of isoelectronics PC, Cl minus Cl and Ca plus is affected by
D. Nuclear charge.
Nuclear charge.
nuclear charge. The one which will have higher value of Z will be smaller. जर ज्यादा होगा तो size छोटा होगा. Yes, please. Rubidium Z37 was the right answer.
Option A.
Sir,
A.
A option.
5s चाहिए मेरे को. 5s चाहिए. Hydrogen, lithium, sodium, potassium, rubidium. Alkali metal, 5s. 500 will be the right answer. 29.
One. Option C.
C. Option 1.
Option C.
जब मैग्नेटिक क्वांटम नंबर स्पेसिफाई कर दे ना, तो मैग्नेटिक क्वांटम नंबर स्पेसिफाई कर दे तो ये पांच में से फर्स्ट ऑफ ऑल आई डोंट डिस्क्रिमिनेट कौन सा +1 है +2 है, पर जब ml का वैल्यू दे दी तो हम लोग एक ही मानेंगे. द वैल्यू इज फ्रॉम -2 to +2. जब मैग्नेटिक क्वांटम नंबर दे देगा तो आई बिलीव इट्स only 1 out of 5 possible. 30.
Option B.
Yet again, this is what I was telling you. The maximum number of electrons in an atom that can have the quantum numbers that given in A and B. 8 and 1. Are you there with me? When they tell you n is equal to 5, ml is equal to plus 1. बच्चे लोग हाँ ना बोलो. फाइव में प्लस 1 के लिए 5p हो सकता है, 5d हो सकता है, 5s हो सकता है और 5g हो सकता है. यहाँ पे l का वैल्यू 1 2 3 4 है. ये सबके अंदर में एक प्लस 1 पॉसिबल है और सबके अंदर में एक ऑर्बिटल एक्सपेक्ट होगा तो 2 plus 2 plus 2 plus 2. There are 8 electrons possible, with this set of possible values. Yes or no? अलग-अलग होगा. But possible plus 1 ये सब में ही है. और naturally जब वहां पर spin quantum number तक गया है, तो they talk about 1 electron. When they tell you that चारों quantum number का value, it means it's Pauli's exclusive principle. This is going to be same. All these four are going to be same. For no 2 electrons, here you talk about 1 electron only. 8 and 1. 31.
B.
Sir, B Bombay.
Simple as it looks. Age-old problem, 5, 5, 4, and 4. B to begin with, then B, then C, and then A. B Bombay, I think everybody has got it right. And plus L value, 32.
B.
Chromium.
12 and 5.
Chromium 12 and 5. Now L is equal to 1 is naturally for 2p and 3p. The configuration 24 is eventually going to be 3d5 4s1. अब 2p में 3 ऑर्बिटल, 3p में 3 ऑर्बिटल, यहाँ पर 6 plus 6, total 12 electrons are going to be there. For which we'll have atomicity quantum number 1. And atomicity quantum number 2 would be only for the 5d electrons, yes or no? This is for L is equal to 1 and this is for L is equal to 2. L is equal to 2, only 3d is a possibility. I think I'm being understood. Question 33.
Option B.
6.
प्लस 2 होने से 3d6 प्लस 3 होने से 3d5. यहाँ पर प्लस 2 है तो naturally 6 is the right answer, not B Bombay but C Calcutta. स्फेरस में 3d6 होगा, स्फेरिक में 3d5 होगा.
Zero.
Last but not the least, 0 is the right answer for F subcell L is equal to 0. Who got all 34 right? Somebody who got all 34 right, please tell me your name. Anyone who got all 34 right?
Sir, Krishna.
Aditya.
Krishna got all right. Aditya got all right.
Sir,
Anyone else who got all right? Yes, please.
Vansh.
One भाई एकदम फॉर्म में है तू तो. और कोई जिसका सारा करेक्ट है? मैं कल बोर्स ऑर्बिट का रेडियस, वेलोसिटी, बाल्मर, लाइनमैन, लैम्डा वो सारा चीज करवाऊंगा. एक बार जल्दी से वो प्रॉब्लम सेट भी मैं अभी शेयर कर देता हूँ, ट्राई कर लो. And this much of the time being, I reckon. Stay happy, stay healthy. Thanks for attending the class. Good night, बच्चे लोग. मिलते हैं. Bye bye.
Thank you, sir.